Hello, my name is Raina Brown.
Maham Babar.
My name is Jess Powell.
My name is Martia Ball.
And this is our pH meter lab video.
The materials used for this experiment were disposable pipettes, beakers, a volumetric flask, a burette, hydrochloric acid, acetic acid, apple juice, orange juice, ammonia.
Here, before taking the pH of our buffer solutions, we first have to rinse off the pH probe with water and gently damp it dry with a Chem wipe. Here, we are measuring our pH 7 buffer solution. But before we can take an accurate pH of our pH 7 buffer solution, we first have to calibrate the pH meter. When calibrating the pH meter is going to ask us to plug in a number for the unknown values of 1 and 2, which happens to be our pH 7 buffer solution. After it is done being calibrated, it is now ready to take the pH of our first buffer solution. Here we are repeating the same procedure and cleaning the pH probe. We are now taking the pH of our buffer 4 solution. Once again, we first have to calibrate the pH meter before we can get an accurate pH of our buffer 4 solution. After the pH meter is done being calibrated, it is now ready to take the pH of our buffer 4 solution.
Buffer is a solution that maintains a relatively constant pH when base or acid is added to it. Buffer solutions are composed of a weak acid and a weak base, usually a conjugate acid-base pair. This allows them to maintain a relatively constant pH by reacting to both acids and bases and neutralizing both. However, each buffer has a limited capacity. Their pH range is limited to about 1 pH unit above or below the pKa of the conjugate acid, so an appropriate buffer must be selected based on pKa values for the desired pH.
Acid dissociates completely into hydronium, or H+ ions, and their conjugate base anions. A weak acid only dissociates partially into their ions. How strong acids dissociate completely, these reactions heavily favor the products and don't reach equilibrium. Weak acids can establish equilibrium because they only ionize partially, so the forward and reverse rates are equal to one another. The effects of strong and weak acids can be minimized by the addition of buffers, which neutralize the reactions and cause a shift in equilibrium.
Here we are cleaning and drying off the pH probe before we take the pH of our hydrochloric acid.
The pHs that we've observed for the solutions were 0.95 for hydrochloric acid.
Here we are testing our acetic acid to get an accurate pH reading. 2.22 for acetic acid. Here we are rinsing and drying the pH probe before we take the pH of the apple juice.
3.58 for apple juice.
Here we are rinsing and drying the pH probe to take the pH of the orange juice.
3.67 for orange juice.
We are now taking the final pH of the ammonia. 11.09 for ammonia.
To clean the probe, rinse the probe with distilled water, shake off excess water and dry with a Chem wipe, then twist the bottle back onto the probe. Power off the meter and replace both the probe and the meter to the box where they were taken from.